Here we go, mathletes. So this is a lesson that's out of the textbook, so I called it No Stacks. And so anyway, this is one I'm a little surprised that the book doesn't have it, but at the same time I understand why. Like, this isn't something that we necessarily need for the definition of the derivative and things like that, but I think it is one of those things that is a somewhat of a staple lesson for limits. Okay. So, and this is limits to infinity. So we've had situations where our limit equals infinity, right? Like if we're approaching an asymptote. We've had situations where our limit can approach positive and or negative infinity, right? From either side or things like that. But what we're doing now is, instead of the limit equaling infinity or negative infinity, what we're doing now is we're actually going to be approaching infinity or negative infinity. Okay. So we're going to have a limit of a function as we approach positive or negative infinity. All right. Now, sometimes this is called end behavior. And we actually talked about this in one of our lessons when we're one of those problems where we're drawing a graph. And it said something like, as x approaches infinity, f of x is, approaches negative infinity, or things like that. So this is along those same lines. We're going to use our limit notation instead of the notation that we saw in that particular example. And so what it says as x approaches infinity, then it would say f of x approaches, infinity or negative infinity, or maybe even zero, or, different things like that, right? This could be just some value here, right? Okay, so instead of that notation, we're going to use our limit notation. But just remember that as x approaches infinity, that means we're going right forever in the function, right? If we approach negative infinity, that means we're going left forever, right? So we're going left and left and left, and we keep going left. So just keep that in mind, that when we have a limit to infinity as we approach infinity, then we're going either one way or the other, left or right forever, which is once again also known as end behavior. All right, so this is from our limits cheat sheet, which I've been posting on our videos, but we haven't really explored it too much, or kind of gone over it a whole lot. But so this is the definition section of the limits cheat sheet, and you kind of have like the precise mathematical definition of what it is, using some maybe unfamiliar symbols and things like that, which, if you want me to explain that anytime, let me know. Then we kind of have like our more like our working definition here, our more kind of common sense, or translation in terms of just common language. This is a good way to think of it. Of course, we have right hand, left hand limits, and then we have infinite limits, which are the ones that approach infinity or negative infinity, or the ones that equal infinity or negative infinity is what I should say, as we approach something else, right? As we approach some value that is going to be an asymptote. That's what we've done before, right? So this is going to be what the new part is with limits at infinity. I say to infinity in this as the title of this lesson, but here we're actually we're letting our input approach infinity, and then we're seeing what our output comes out to be, right? And sometimes that output could still be infinity or negative infinity, but it also could be some other value. Okay, so yeah. So anyway, as we're approaching positive infinity, once again we're going to the right. We're going right forever, and so it's large enough and positive, right? And then if we go to negative infinity, that means we're going left forever, and those are large and negative values, right? So absolute value y is large, but negative in the negative direction, right?